Okay, so now we're going to learn how to factor by grouping using an area model. You know you have to factor by grouping because you have 4 terms. Now, what's very important here is to correctly factor this. You want to make sure that your terms are arranged in descending order, meaning the highest exponent comes first. Because when you start filling out your box, you want to make sure that the term with the highest exponent, which is called the leading term, has to go in the upper left box, and then the term with the lowest exponent goes in the lower right box. The middle two terms don't really matter. I usually go from left to right, left to right. So all we did is we filled out our box. So this is the area of our box, is the sum of all the 4 areas. And now we're going to factor. So the way we're going to do this is we are going to choose a column or row and find a greatest common factor for the column or for the row. It doesn't matter where you start because you just need to get one number or one term. So I'll start with this row. I have 3x plus 1. They don't really have anything in common, so I'm just going to take out a factor out of 1. And then once I have this 1, I'm just going to work backwards. So for example, 1 times something gave me 3x, so this term here has to be 3x. 1 times something else gave me 1 as an answer, so this has to be a 1. And then 1 times something gave me 5x squared, so this has to be 5x squared. And then I'm going to take a couple 2 seconds and just double check. When I multiply 5x squared by 3x, I do get 5x to the third. When I multiply 5x squared by 1, I do get 5x squared. When I multiply 1 by 3x, I get 3x, and 1 times 1 gives me 1. So I quickly double check that everything works out. So then we're done. Our factored form of this rectangle is going to be written as 5x squared plus 1 multiplied by 3x plus 1. They both represent the area of this rectangle. We just write them in different forms. On the right, we have factored form, which is equivalent to length times width of this rectangle. And on the right side, on the left side, we just have it as a sum of 4 smaller areas. Okay, so here we're going to fill out the box. Our leading term goes in the upper left. Our lowest term goes here, and then I fill out the 2 middle ones. It's going to be a little different because if you notice, we have these 2 negatives, so we also have to consider the signs. Okay, so first I'll start here. I have negative 8x and 7, and my first term is negative, so I'm actually going to factor out a negative, and they don't really have anything in common, so I'm going to factor out a 1, or negative 1. Negative 1 times something gave me positive 7, so this has to be negative 7. Negative 1 times something gave me negative 8x, so this has to be 8x. And then I just have to figure out what comes here. I'm going to use 49 because it's a little smaller. Negative 7 multiplied by something gave me negative 49x squared. So this has to be positive 7x squared. And I'm going to double check. 7x squared times 8x is going to give me 56x to the third. So then I'm done. My factored form is going to be length times width of this rectangle. So I'm going to write it as 7x squared minus 1 multiplied by 8x minus 7. And then that's it. That's your factored form. Alright, so we're going to fill out our box. Our leading term goes here. Negative 3n squared, negative 2n plus 3. And then we're going to look for common factors. I'll start with this column. I have negative 3n squared and 3. This is the leading term, I guess, for this column, and it's negative. So I'm going to take out a negative. 3n squared and 3 have a 3 in common. And then I'm going to work backwards. This is going to be negative 1, because negative 1 times negative 3 gives me positive 3. This is negative 3n squared, so this has to be n squared. And then n squared times something else gave me 2n to the third, so this has to be 2n. We're going to double check. 2n times negative 1 is going to give us negative 2n squared. So now we're done. We have length times width of our rectangle, which is the factored form. Now, technically speaking, we can actually factor this more, but this is a special case and we're not going to address it here. But for those of you who know how to factor this further, you can keep factoring and actually break it up this polynomial into more factors. So this is our last example for 4-term factoring. I'm going to put my leading term here, my lowest term here. You have 10v squared and negative 28v. Looks a little different. So if you notice, we have a negative row, so our common factor is going to be negative over here. What do 10v squared and negative 35 have in common? They both have a 5 in common. If you notice, 10v squared is not negative, so I do not factor out a negative, just the 5. I'm going to work backwards. 5 times 2v squared gave me 10v squared as an answer. 2v squared times 4v gave me 8v to the third, and 4v times negative 7v, actually I don't need a v, just negative 7, gave me negative 28v. I'm going to double check. Negative 7 times 5 is going to give me negative 35. So now I'm done. This is my factored form of the polynomial. So 2v squared minus 7 multiplied by 4v plus 5.